In the previous steps, we implemented persistence and business logic for our microservice. Now we are ready to expose that functionality to external consumers. There are several popular protocols in the industry, like REST or gRPC, and it's not hard to implement them in using Pip.Services toolkit. But I can show you even an easier method. It is based on commendable pattern. Our controller must implement a commendable interface and return a command set. Then a special commendable HTTP service will generate an HTTP interface based on that command set with just a few lines of code. Let's see how it's done. Let's go to controller and uncomment iCommandable interface. We also need to uncomment command set field and get command set method. As you see, this method is using lazy initialization and creates command set on the first run. Then we need to add beacons command set class into our project next to the controller class. In this class, we'll inherit command set base class from Pip.Services toolkit and create a few commands. So each command has a name, validation schema, and execution function that will be called when command is executed. In the execution function, we'll be receiving correlation ID and set of parameters, unpacking those parameters, making call to the controller, and then returning the result value as a result of command execution. The first command will be get beacons. It will receive two parameters, filter and paging. We'll be using predefined validation schema for them. And in the execution function, we will unpack those two parameters, call a get beacons method on the controller, and returning the result back. The next command will be get beacon by ID that will receive a beacon ID string parameter. The next one, get beacon by UDI. Similarly, it will receive UDI parameter as a string type calling controller. Calculate position. Site ID is a string parameter and UDIs is array. We'll have create and update and delete operations or commands in the command set. When we need to convert values that we receive from the parameters, we can use just simple conversion from and to JSON that will allow us to convert value from the parameter set to the beacons object. We can use a different method for optimization, but for simplicity, this method will work just fine. As we have our command set, we can implement commendable HTTP interface. Create services folder under service project, and since our external interfaces must be versioned, we'll be putting a version 1 folder underneath it. In this folder, create beacons HTTP service version 1. And as I promised, this class will have just 5 lines of code. We'll inherit commendable HTTP service from Pip.Services toolkit. In the base constructor, we will pass the root path that will be version 1/beacons. When we need to implement version 2, we will be changing this base path to v2/beacons, and it will help us to resolve any collisions on the routes. Then we need to define locator for our controller so HTTP service can find it among the references. We'll specify beacons as the logical group, controller as the logical type. It will be default implementation type, any name, 1.0 version. So once again, using this descriptor, HTTP service must find controller its references. That's all what is required. So what will happen in the runtime? The commendable HTTP service will scan the references, find the controller, see if this controller implements a commendable interface, retrieve command set, and using that command set, it will expose a few HTTP operations. When operation will be called through commands, it will be calling controller and receiving the result back. The next step is to implement automated tests for our service. Create services and then version 1 folders in the service test project and put the beacons HTTP service v1 test class. This test will be very similar to our controller. We'll be creating two test beacon objects, and in the test constructor we'll create a few components and configure them. Then we'll be setting references. So we'll be creating a memory persistence, controller, HTTP service, and in order to call HTTP service we'll be using test commendable HTTP client from Pip.Services toolkit. For this client we'll be specifying the root path that is identical to HTTP service. Then we'll create a set of references. We'll be specifying descriptors as we did it on the previous step, and we'll be including their persistence component, controller, service, and the client. Then we'll be calling set references in the controller component so it can find persistence. We will be configuring HTTP service, and in the configuration parameters we'll be setting a protocol to HTTP, host to localhost, and our port will be 3000. So we'll be passing these configuration parameters to the HTTP service, and then we'll be calling set references method that will help the HTTP service to find a reference to the controller component. After that we'll be configuring client with the same parameters as our HTTP service so it can connect to it. We'll be opening service and opening client. At this point client should be connected to the service. In the test we'll be calling our HTTP service through the test client using call command method. The signature of this method is similar to the command parameters that we just saw. The first parameter is the command name, then we'll be passing a correlation ID and the set of parameters. We'll be creating the first beacon and testing that the beacon was created correctly. We'll be creating the second beacon, calling getBeacons method with empty filter and receiving exactly 2 beacons. After that we'll get the first beacon, change human readable name, call update beacon operation, and check that the beacon was updated correctly. After that we'll test getBeacon by UDI method. We'll be passing UDI and testing that the beacon that we received is exactly the beacon that we requested. And at the end we'll be deleting the beacon by ID and trying to retrieve the deleted beacon, but we should receive null. Let's build the project and run our automated tests. All the tests executed successfully, so we are ready to go to the next step. Now we have almost everything what we need for our microservice. We have a way to store data into the database and then retrieve it. We implemented business logic, and we put together an interface for external consumers. The next step is to put all these components together and run it as a system process. Let's see how we can do it in our next step.